Hello, children. Welcome to Riot Tuition Classes. We are doing extra lecture 2, extra sums on Pythagoras theorem. Okay. Now look at this triangle, children. Triangle ABC is right angled at B. You can see a triangle ABC is right angled at B. And D is a midpoint of BC. If D is a midpoint of BC, don't you agree AD is a median? AD is a median. Anyhow, what do you want to prove? AC square equal AC square. Can you see this red segment AC square, children? Can you see this red segment AC square? Children, can you see the red segment AC square? This is AC square. Red segment AC square, children. We have to show it is equal to 4 times AD square is equal to 4 times AD square. Look at AD square, children. This yellow segment is AD square. This yellow segment is AD square. Okay. This AD square is involved. Minus 3 times AB square. Minus 3 times AB square, children. You can see this blue segment. Okay. The blue segment is involved. Okay. What is that? AB square. Now, just think of a segment. Please have a look here. I told you last time what I was saying. When you see square of the segment with plus sign or minus sign, you have to think of Pythagoras theorem. Pythagoras theorem is always that. Option is that. Okay. But look at these three segments which are involved. AC is a hypotenuse. Okay. What is AD? AD is a median. And what is AB? AB is a perpendicular side, 90-degree angle का. ये तीनों segments involved हैं. Hey, don't you realize whenever you see AD, you can always think of Apollonius theorem. I hope everybody knows Apollonius theorem is sum of the squares of the segments on either side of this median. AD is a median. Which side are there on either side of it? AC and AB. So AC square plus AB square equal. Twice, AD square plus BD square. Twice the sum of the squares of the median and the bisected part of the side by the median. So naturally, when you use Apollonius theorem, at least three majority of the segments come. And then somehow I have to get rid of this BD square. Okay, I think fairly simple. So what am I going to do? In my proof, I'm going to write, please have a look here. I'm going to write in triangle Pythagoras theorem. Okay, in triangle proof. Okay. See, not Pythagoras theorem, in triangle ABC. Okay, I can say segment AD is a median. Segment AD is a median. Now somebody will say, sir, it's not given, but a segment joining a midpoint of a side and the opposite vertex is called a median. D is a midpoint of side BC. A is the opposite vertex. So AD is a median by definition. Okay, by definition. Okay. By definition of median. Okay, just say by definition. Okay. Now, if AD is a median, what is Apollonius theorem? Sum of the squares of the segments on either side of the median. AD is a median. Which segments are there on either side of it? AC and AB. Sum of the squares of the segments on either side of the median. That means AC square plus AB square. Okay, sum of the squares of the side on either side of the median is twice sum of the squares of the median and the bisected part by the median. Which are the bisected parts? Either CD or BD. I go for BD, children, BD square. Okay. The reason for it, I call this as statement number 1, and I call it as Apollonius theorem. No need of saying it as statement number 1, children. We'll simplify this, and then later on we can call it. Okay, number Apollonius theorem. This is by Apollonius theorem. By Apollonius theorem. By Apollonius theorem. Now, when you look at it, children, okay, AP, okay. Now listen here, children, all are going to pay attention here. When I open the bracket, AC square plus AB square equal twice AD square plus twice BD square. And you can clearly see, children, you don't want, which segment here, you don't want this BD. You don't want this BD, okay? I don't want this BD. I call this as 1, okay? I don't want this BD. BD, I don't require it. So BD need not be there in your answer. You can see here, okay? We want AC square. We want this AD square. I want this AB square. But I don't want this BD square. I don't want this BD square. So this BD has to be get rid of. Oh, BD is also a side of a right angle triangle ABD. I can easily get rid of BD square. See, in triangle ABD, in triangle ABD, angle ABD equal 90 degrees given to us. So what will be popular? What will be Pythagoras theorem? Just have a look here. Now I want to get rid of BD square. So naturally AD square equal AB square plus BD square by Pythagoras theorem. So look at this statement very clearly, children. And from here, you don't want that BD square. So don't you agree from this statement, what is BD square equal? BD square, what is it equal to? AB square, AD square. I'm so sorry, children. It will be AD square minus AD square minus BD square. That plus BD square, bring it this side. Sorry, I'm so sorry, children. Okay, yeah. I don't want, okay, I don't want this. Please have a look at this. I don't want this, what, BD square. So AB square, I move it this side, minus AB square is equal to BD square. Can you see here, children? Now, what I do, this is my statement number 2. So from here, the value of BD square, you got it, children. What is that? AD square minus AB square. Can I substitute? So AC square minus AB square. I'm rewriting this statement number 1 equal twice AD square plus 2 into, please have a look here, what is BD square? AD square minus AB square. AD square minus AB square. Now you can see your children reason is from 1 and 2. Now just simplify, I'm sure you should get your answer. AC square minus AB square is equal to twice AD square plus 2 into AD square is 2AD square minus 2 into AB square is 2AB square. Now you can see your children, your like terms, this AB square and this AB square. Okay, this AB square and this AB square, you can see here, children. What will happen? If this is, okay, so you can see, children, AC square is equal to, what will happen? Twice AD square. Twice AD square plus 2 into inside the bracket. What is this, children? Please have a look at this. What is this? 2 into, what is BD square equal? BD square equal AD square minus BD square. Oh, sorry, children. You're already substituted. Okay, in place of BD square, you put AD square minus AB square. So it becomes 2AD square minus 2AB square. Okay, so what will happen, children? Now, AC square, this AB square, bring it this side, AC square equal. Okay, 2AD square plus 2AD square is 4AD square minus 2AB square plus AB square. So what will happen, children? Okay, here it will become AC square equal 4AD square and minus AB square. Mr. Gardner. Just a mistake I was doing, children. This AC square plus AB square equal twice AD square plus 2 into AD square minus AB square. AC square plus AB square. This I put minus sign. Okay, equal twice AD square plus twice AD square minus 2AB square. So what will happen here, children? Just have a look here. That's why I realized there is some mistake going on. Okay, so you can now see, children, what will happen? This AC square plus AB square, twice AD square plus twice AD square is 4AB square minus 2AB square. And this plus AB square, when it comes this side, it is another minus AB square. So ultimately it becomes minus 3AB square. Okay, so AC square equal 4AD square minus 3AB square. You can clearly see, children, we have got the answer. One time Apollonius theorem and one time Pythagoras theorem. I hope people understood me. I don't think it's a difficult sum, children. It's a one silly mistake that I've done it. Okay, I'm sorry for it. We go to the next sum, children. Question number 6. Question number 6, children. P and Q are points on side AC and CB respectively. You can see here, P and Q are the points on AC and BC respectively of triangle ABC right angle at C. Now, one thing you can see here, children, they are not given it as, they are not marked it as midpoints. Okay, whereas I marked it as midpoints here. No, they are not midpoints, children. They are not midpoints. P and Q are not midpoints. Okay, what I'll do is, please have a look here. I had to rub it off and draw it once again. But anyhow, P and Q are not midpoints. By mistake, I marked it as midpoints. Please don't take it as midpoints. Now look here. Look at AQ square, children. Okay, whenever you want, square of the segment is plus sign. I always told you, look for the right angle triangle whose side it is. So AQ is a side of which right angle triangle you can see here. AQ square I want. See, plus sign is there. BP square, AB square plus PQ square. So I realize Pythagoras Theorem chapter ka. Then every segment, AQ square is a side of which right angle triangle? When I look at it, I can realize, children, I can realize it's a side of right angle triangle QC. You can see a QCB. I can say it's a side of right angle triangle QCB. Then comes, children, BP square. Let's see, this BP square is a side of which right angle triangle? When I look at BP square, children, I can see it's a side of this pink color right angle triangle. Pink color right angle triangle. Okay, pink color right angle triangle. Little it will become out of shape, doesn't matter, just to help you understand. So you can see here, children, AQ belongs to the red right angle triangle, BP belongs to the pink right angle triangle. Okay, then when I look at it, AB square, children, AB square, when I look at it, AB square, children, AB square, AB is a side of the right angle triangle. You can see here, children, BC, green right angle triangle. Is your AQ is the side of the green right angle triangle. Okay, green right angle triangle. Okay, now you can clearly see, children. Okay, now we go ahead, children. One more segment is left, PQ. And when I look at PQ, children, this PQ is the side of this yellow right angle triangle. PQ is the side of yellow right angle triangle. So सबसे छोटा right angle triangle जो है, okay, PQ square है. तो आप क्या देख रहे हो? Please have a look here. And what I wanted to show you all was there are four segments, four right angle triangles. Four segments and four right angle triangles. You can see every segment belongs to one right angle triangle. Like AQ square मांगते तो आपको रेड राइट एंगल ट्राइंगल लेके पाइथागोरस थ्योरम यूज करना पड़ेगा. बीपी स्क्वायर मांगते तो आपको पिंक राइट एंगल ट्राइंगल लेके उसमें पाइथागोरस थ्योरम यूज करना पड़ेगा. और AB स्क्वायर लेगा तो आपको ग्रीन ट्राइंगल में लेके पाइथागोरस थ्योरम यूज करना पड़ेगा. Okay, children, and if you take, please have a look here, if you take PQ square, आपको येलो राइट एंगल ट्राइंगल लेके पाइथागोरस थ्योरम यूज करना पड़ेगा. So four segments and four right angle triangles. You can see here, children, four segments and four right angle triangles. So such a easy sum. So whenever you see like this, four segments are there in the question, and there are four right angle triangles. Each segment belongs to one right angle triangle. Then very simple question, children. You can just follow it. It's so easily you can do it. Like first get AQ square. Go in order. If you want to get AQ square, what are you going to do, children? If you want to get AQ square, you're going to take first this right angle triangle QCA. So in triangle QCA, just have a look at this, okay, QCA, okay, angle QCA equal 90 degrees. Angle QCA equal 90 degrees is given to us. Got it, children? So what will happen, children? Why, whenever you want to use Pythagoras theorem, first the name of the triangle, then get the 90-degree angle, then use Pythagoras theorem. What is that? QA square equal QA square equal QC square plus AC square. I hope everybody can see it. Call it as 1 by Pythagoras theorem, by Pythagoras theorem. Now, when you look at the next one, children, the next one, BP square. BP is the side of this pink right angle triangle. BP is the side of pink right angle triangle. So in triangle, please have a look at the pink triangle. In triangle BCP, angle BCP equal 90 degrees. Angle BCP equal 90 degrees given to us. So what will be Pythagoras theorem, children? BP, please have a look here. BP square you want. BP square equal, please have a look at this, BP square equal BC square plus PC square by Pythagoras theorem. Step number 2, by Pythagoras theorem. Now when you look at this question, children, please look at the question what you want. You want this AQ square and BP square to be added. AQ square and BP square to be added. So I'll just add this stated number, adding 1 and 2. I'll add 1 and 2. When you add two statements, children, the left hand side gets added up. So what will happen? QA square plus, what is this? BP square is equal to, children, what will happen? QC square. Okay, the right hand side will get added up now. QC square plus AC square plus BC square plus PC square. I call this as statement number 3. You got this by adding 1 and 2. You got this by adding 1 and 2. Now I want AB square. Right hand side me AB square. AB belongs to the big right angle triangle, children, in triangle BCA. Angle BCA equal 90 degrees. Okay. So what will be your, you wanted AB square. Can I use Pythagoras theorem, children, here? So what is AB square going to be? AB square going to be BC square plus AC square by Pythagoras theorem number 4, by Pythagoras theorem, by Pythagoras theorem, by Pythagoras theorem. Then, children, look at the next segment. What is that? PQ square. Look for PQ. PQ is a yellow segment. PQ is a yellow segment. So in triangle QCP, okay, angle QCP equal 90 degrees. Angle QCP equal 90 degrees given. Angle QCP equal 90 degrees given. So what it will be, children? QP square equal, yeah, PQ square equal, PQ square equal QC square plus PC square. What's the reason, children? By statement number 5, by Pythagoras theorem, by Pythagoras theorem, by Pythagoras theorem. Now you can see here, children, adding, children, adding 4 and 5. When I add 4 and 5, you can see here, children, AB square plus PQ square, AB square plus PQ square is equal to BC square plus AC square plus QC square plus PC square. This is your statement number 6. Now, please look. First, you wanted AQ square plus BP square. I got AQ square plus BP square. Now, I wanted AB square plus B. I got, look at the right-hand side of the statement number 3 and 4. Just look at the right-hand side. QC square. Don't you agree? QC square is here. Okay, QC square is here. AC square. AC square is here. BC square. BC square is here. PC square. PC square is here. The right hand sides are same of statement number 3 and 6. Same 4 segments, same 4 segments. Right hand side same है. So left hand side equal हो गया. Therefore, QA square plus BP square is equal to AB square plus PQ square. Reason is from 3 and 6. From 3 and 6. I hope people have got me here. A very simple sum, children. This was your question number 6. We go to the next sum, children, now. Question number 7, children. In the adjacent figure, S and T trisect. S and T trisect segment QR. Now, what is the meaning of this? S and T trisect segment QR. S and T trisect. That means all these 3 segments are equal. QS equal HT equal RT. That is what they mean. Okay, S and T trisect segment QR. Okay, S and T trisect segment QR. So I just like a proof, very simple and very, what you can see, a totally different type of proof, children. You will see here. What is this? First, S and T trisect QR. Okay, I'll be using it little later. QS equal ST equal TR. Got it? What is this? Statement number 1. I just call it as statement number 1 given. Okay. Now you can see, children, you want 8 PT square. Okay. So how I go about how to get PT square? PT is the side of right angle triangle PQT. So I go for this triangle PQT, children. In triangle PQT. Okay. Angle PQT equal 90 degrees. Angle PQT equal 90 degrees. See, whenever you want to use Pythagoras theorem, it's a way of writing. First the triangle's name, then the 90-degree angle, then Pythagoras theorem. So Pythagoras theorem क्या आएगा बेटा? PT square equal PQ square plus QT square. What's the reason, children? By Pythagoras theorem. By Pythagoras theorem. Okay. After getting this, children, this is my stated number. Therefore, now look, I want 8 PT square. So just multiplying by 8 PT square, 8 throughout. 8 PT square equal 8 PQ square plus 8 QT square. Okay, 8 QT square. Reason, multiplying stated number 1, the 2 I call it, multiplying throughout by 8. Multiplying throughout by 8. I'm not throughout by 8. Nothing. I have not got an answer yet, children. I just throughout by 8. Okay. I've got multiplying throughout by 8. Okay. Then, children, I got 8 PT square, but I want this 3 PR square. PR is the side of right angle triangle PQR. So in triangle PQR, okay, angle PQR is equal to 90 degrees given to you, children. Angle PQR is equal to 90 degrees given to you. So what is going to be? PR square equal PQ square plus QR square by Pythagoras theorem. Stated number by Pythagoras theorem, children. By Pythagoras theorem. Now look at, children. I wanted 3 PR square. So just multiply by 3 throughout. 3 PR square equal 3 PQ square plus QR, 3 QR square. 3 QR square. 3 QR square. Okay, I hope everybody can see it. Okay. Oh, I'll rewrite once again. 3 QR square. Okay, what it is? Plus 3 QR square. Okay. This is statement number 3 multiplying by 3 throughout. Multiplying by 3 throughout. Okay, multiplying throughout by 3. Multiplying throughout by 8, it was multiplying throughout by 3. Multiplying throughout by 3. Okay. The next, I got this. This is my step number 3. Now I want 5 PS square. So in triangle PQS, angle PQS equal 90 degrees given to me. Okay, so naturally, what it will be, children? Therefore, PS square equal PQ square plus QS square by Pythagoras theorem. By Pythagoras theorem. Oh, now that is going to be, listen, but it is 5 PS square. So 5 PS square, I'm multiplying 5 PQ square plus 5 QS square. The reason is multiplying, this is my statement number 4, multiplying throughout by 5. But you want 3PR plus 5 PS square. So what I do, children, I add state number 3 and 4. I add, now there's no place, so I'm rubbing off this question, children. I remember what is given, but anyhow. Okay, so see here, children. Now, what I do, I just multiply by I want this 3PR square plus 5PS square, adding 3 and 4. What I do? Adding 3 and 4. When I add 3 and 4, what will happen, children? The left-hand side gets added up. 3PR square plus 5ps square. 3pr square plus 5ps square equal 3pq square plus 5pq square is 8pq square plus 3qr square 3qr square plus 5qs square 5qs square. Got it? This is adding 3 and 4. That is your stated number. You can call this as 5. Okay. Now listen. You got 8pq square, but this 8qt I want 8qt. Somehow I want 8qt square in my answer. Got it? So you can see here this 3qr square and 5qs square. 5qs square. So what is, please have a look at this. What is this QR? QR is, you can see here, QTs. I want people to understand. S and T are the points of trisection they are said. That means if you ask me what is QT, QT is 2/3 of QR. QT is 2/3 of QT is 2/3 of QR. Got it? I want in my answer, please have a look here. I want in my answer here 8qt square. Got it? So naturally, children, see what I do. Got it? So everybody just have a look at this. Got it? So what I'll do is 1 minute. So what is QR equal 3 by 2? QR equal 3 by 2. QR equal 3 QT upon 2. So QR equal 3 QT upon 2. I call this as statement number 6. Got it? Why did I do like this? I just want to get rid of this QR. Okay. In the same way, I don't want this QS. So QS is half of QT. So what will happen? 2QS is equal to 2QS equal QT. Got it? So I'll just say, please have a look here. I don't want to get QS. So QS is half QT. Got it? The reason for these two statements are, I hope people understood, okay? Because I just write stated number, actually from 1 it happens, but I'll just say points S and T, points S and T trisect segment QR. Now what is going to happen, children? You're going to, please have a look here. You just look at this, okay? 5ps square, you want to, sorry, where have we got this 3pr square plus 5? Here. Just have a look. 3pr square plus 5ps square is equal to 8pq square plus 3 into 3 upon 2 qt square plus 5qs square, 5 into 1 upon 2 qt square. Now just simplify this and you see what answer you get. Therefore, 3pr square plus 5ps square is equal to 8pq square plus 3 into 9, 27, 27 upon 4 qt square plus 5 into qt square upon 4. So what happens? 32, children. So you can see here, I'll just rub this question. I'm getting the answer, children. Please have a look at this. I'm going to get the answer. Therefore, please here, 3pr square as it is plus 5ps square is equal to 8pq square plus, okay, when the denominator is same, numerator gets added up. So 27 plus 5, 32 qt square, 32 qt square upon 4, which is nothing but 8. So what do you get? 3pr square plus 5ps square is equal to 8pq square plus 8qt square. You can call this as statement number 8. And now you got your answer, children. Compare your stated number, compare your statement number 1, okay? The right hand side of statement number 1, when you compare statement number 2, children, when you compare the right hand side of statement number 2, and when you compare the right hand side of statement number 8, the right hand sides, okay, it is same. So naturally, can I say, children, can I say 8 pt squared equal 3 pr squared plus 5 ps squared? The reason is from 2 and 8. I don't say it's difficult, children, but still, you have to concentrate a lot to understand it, okay, children?